There we go. Okay, so they missed cost and revenue, but it'll be all right. So we've got our cost 20Q plus 6,000, revenue 50Q. So then we go to do our profit function. Remember, that's revenue minus cost. So our revenue function of 50Q minus our cost function. Always put that sucker in parentheses so you remember to distribute the negative. So then if we distribute the negative there, we've got 50Q minus 20Q. So 30Q, and then minus 60,000. I don't know, I never thought to do this before. It's cool. All right, any questions on that one? Alrighty, break-even point. So remember, break-even point is defined to be when profit equals 0, or you can find when revenue equals cost. It's going to give you the same exact thing. Since we have the profit function, why not just set it equal to 0? So 30Q equals 60,000. Q is therefore 2,000. Yeah.
Can you also do cost and the revenue to each other?
Yeah. So if we had set 50Q equal to 20Q plus 6,000, subtract 20Q from both sides. Yeah, you're essentially right there. So yeah, either way, whatever floats your boat. I'm going to need this space, so I need to erase it. But remember, for break-even point, I always want the break-even quantity and break-even price. I'm very specific about that on the quiz. It's in the instructions. So to find the break-even price, we take that quantity and plug it into either cost or revenue, whichever one makes you happier. I usually plug it into revenue. That does not look like a 2. What just happened? Where am I? See my screen. That's not good. Can you see it now? You see now, Brianna? Okay. So if we plug that into revenue, we have 50 times 2,000, which gets us 100,000 as our break-even price. I got asked this in my other class. Do I have to write it as an ordered pair? No, as long as you have both values somewhere. It would be nice if you could box them or whatever, but as long as they're there, I'll find them. Questions, concerns on that part? Yeah. No, you could totally go. So my break-even point is 2,000 and 100,000. That's fine. Yeah, if you're used to doing it that way, go right ahead. Whatever floats your boat. Ready? So number 2, so in terms of the exponential stuff you'll need for your quiz, this is the extent of it for the quiz today. So if you can, or feel, if you feel comfortable with this question, you should feel comfortable on your quiz. So a bacteria population starts with 2.75 million bacteria and grows at 5% per hour. Find the exponential equation to represent the amount of bacteria after 2 hours. How many bacteria are there in 3 hours? Ooh, speed read. So remember, for exponential functions, we've got some P naught a to the t, where P naught is the initial condition. So the initial value here. So if you wanted to write the actual point, you can just have them, you know, like this. But if you wanted to write the full point, you would write it like this. But feel free to just keep them as separate values if you wish. Whatever makes you happier. Okay. So the initial value, scroll back down. The initial value is our 2.75 million. And we're told that we're growing at 5% per hour. So we have an A value, but remember that the A value is made up of 1 plus R. and R is what you're actually given 95% of the time. So if you ever see the word rate, the word percent, or the percent symbol, you're given R, not A. So here we know that R is equal to 0.05 because I also have to convert it over to a decimal. So let me just count 5% over here so we know where that came from. So that means my A value is 1 plus this 0.05. So 1.05. What am I doing? Sure. Which means that my equation is 2.75, 1.05 to the t. And then technically we're also asked how many bacteria are there after 3 hours. So we would take this equation and plug in 3. I'm going off of memory here. 3.18. Yes. Million bacteria. That was seriously from memory from yesterday. What up, person in class?
What?
No, go ahead.
Should it be up to 100th place or I say 1,000?
If you take 3 decimal places, perfectly fine. If it doesn't specify however many decimal places makes you happier, I would personally say at least 2 or 3. But if it doesn't specify, you can do whatever. What up, Faith?
So I see that on A equals 1 plus 0.05. Where does that 1 come from?
Good definition. I wasn't trying to be sassy. That's just literally the answer. Let me try to explain it a bit better though. So let me fall all the way back. I gotta pull it up really quick. Give me a second. 1 second. I need this, and then I need to do this. So when we talked about 1.5, in the full definition, we're just told that A is 1 plus R. Why does that come into existence? The reason it's kind of there is because if you grow by 5% per year, you also still maintain the, like, think about it as a population, if you will. If your population grows by 5%, you still maintained the original number of people that you had and you just gained 5% more, right? So that 1 is kind of making sure that that initial group stays around in the calculation, if you will. So that's why the 1 kind of exists, because if we just multiply it by 0.05, we're going to get something small. And it's not like the population suddenly went from 1,000 to 50. I don't think that's the right number, but you get what I mean. So we have to have this 1 kind of placeholder there to say that the original population is staying and we're adding on top of it. So that's kind of the idea behind it. But the reason it's there is also just because we're told it is. Does that make sense, Faith?
Yes, it does. Thank you.
You're welcome. Okay, so I've got a couple other things. Rihanna first. Let's go.
Okay, so then, sorry, if you already said this, I must have missed it, but on like quizzes and tests, are we going to be given any of these equations, or will we have to recognize, like, just know what to do?
You'll have to know what to do, unfortunately. So, yeah, no, that's just, I don't know what else I was going to say about that. You'll need to know if it's linear, it's y equals mx plus b. If it's exponential, it's p naught a to the t. So you'll need to know and be able to recognize the formats for each type of equation.
Okay, thank you.
And then Brianna, can you go back to the first problem for, yeah. The first problem being the cost, revenue, and profit one? Is there something specifically you wanted me to talk about in terms of it, or did you just need to look at it really quick? Okay. I'll give you a couple more seconds on that. So we're going to continue 1-6 today, most likely finish 1-6, and then move on to 1-7. Note that your exam's coming up. It's next week. So some things about that. So I'll leave this up for a couple more seconds while I babble about that. If you're my English broke. If you're with the Office of Disabilities and you need to take your extended time, you need to take it with them, okay? I can try to stay here for a couple more minutes afterwards if you don't think you need the full extra time, but if you want to take your extra time, even if you don't think you're going to use it, if you want to be able to take your extra time, you need to take it through their actual office. That's one thing. I'm going to ask that if you are able, so this might be partly more for the people on team, but no, it's for everyone. If you are physically able to get here, so you're not quarantined, you're not isolated, you're not whatever, I'm asking that you be here for the exam date, even if you would usually pop in online, okay? This is technically a hybrid course. You're technically expected to be here. And I know the world's exploding right now. But if you can be here, I expect you to be here next week on Thursday. I will also be trying to get out a review packet on Blackboard. I'm hoping to get it out on Friday, but it might lag till Saturday. But that'll be out, and I'll post the answers a few days afterwards, probably after Tuesday. We do have a bit more content to cover on Tuesday, so we will have a bit more content before the exam. If we have time, I would love to be able to spend part of Tuesday kind of reviewing and maybe going over that packet or whatever. But the main thing I have to focus on is getting through that last piece. It's only one other section. It's 1-8 that is highly important that we need to get through. I'm trashing 1-9, but 1-8 we have to get through. So that's going to be on Tuesday. Possibly may need to finish 1-7. But anyway, is there a question?
Do you, like, if we're just taking a quiz on Thursday and we don't like anything, mind if we do online?
So in terms of quizzes, I don't mind as much if you want to do them online, because quizzes are, I don't want to say they're less important, but you know, they're less important than an exam. So with the exam, I'm being a bit more strict. But in terms of quizzes, it's if you aren't here, then they're online. You first.
Is our, like, quizzes a good way to study for the exam?
So in terms of exams, think about it this way. I write the exams, I write the quizzes. So the better things to look at are, like, think about the warm-ups that we do, think about the quizzes that I've given you, look at the review sheet that I will have created, as opposed to like looking at Wiley, because Wiley creates those questions. I might choose the questions on Wiley, but I don't write them. Also, I just remembered, I'll get to your question in just a second. Wiley, I sent out an email about a question on Wiley, and then I immediately remembered another one that's dumb as well. I can't remember the name of it, the number. But what happens is it has like a bunch of blanks, and it's like billion people here, billion peeps, and then it's billion peeps here. And then all of a sudden, for the last blank, it changes to millions, because why not? I don't know. Anyway, I always forget that it does that for that question. I always mean to remove it every single semester, and I always forget. So like you'll get something like 0.008. I think it's usually like 0. This is the number you'll get when you do the calculation, but the actual thing it wants is 85. So that's a thing. What A, email me. But B, if you're typing in something like 5 times 7 to the t, how I would do it is 5 parentheses 7 parentheses little caret t. There is usually a little equation editor button that you can click, but sometimes even using the equation editor, Wiley kind of panics and makes your equation not what you think it made it. So just shoot me an email with the numbers and I can look into it. Finally, your question.
Will we have the entire time for the test next Thursday?
Yes. Oh, yes. I was like, that's a silly question, but no, I guess people could take half the time to do more content, I guess. Yeah, you have the entire 75 minutes. I usually write like, so here's how I write exams, and I know people are posting in chat. I'll get to those in a second. Here's how I go about writing exams. I write the exam and then I have to take it. I take it and then I figure out how long it took me to take, and I multiply that number by 5, sometimes by 4, but usually 4 or 5, and that number that I get from that has to be around 75. So I'm essentially giving you guys 5 times the amount it would take me, because obviously I know this stuff like the back of my hand and you guys don't. So usually it turns out to be like a 60-minute exam, quote unquote, where like most people can finish it in 60 minutes. Maybe some people need a full 75. Maybe some people complete it in 45. But I try to get like a little bit of a sweet spot where it's not going to like take the average person the entire time, but you know, a decent amount of the time. What up?
Is the format, what's the format of the exam?
The format of the exam. I'm thinking about it. Well, no, anyway, there's multiple choice. There might be some like fill in the blanks, but I usually don't do those. But anyway, and then there's usually a good bit of full response. Now I will say, now yes, I just said that I'm expecting most of you to be here. Of course, there are. Am I allowed to say that? I don't know if I'm allowed to say that. So in a very few amount of situations, they will be online. And so I'm also trying to reformulate my usual exams so that it's fair on both ends. I don't, you know, so if I were to give a purely online exam, there would be things like find the error, where I give, you know, completely worked out something and you have to figure out where the error is. So there might be something like that. I'm still playing around with it a little bit. I'll try to make my review packet have the types of questions that you'll see, or the question types that you'll see. So if I'm planning to put a find the error, you can expect to find an error on the review packet. So not quite entirely sure yet, but usually my exams are multiple choice and then free response.
Would it be like any definitions?
No, I never test definitions, and by definitions I assume you need what is the definition of blah blah blah. I don't do that. How I kind of think about it is if I ask you for the average rate of change and you don't know what the definition of average rate of change is, then you won't be able to answer the question. That's how I quote unquote test definitions, but I never ask what is the definition of blah. Let me get to some of these really quick. How do we take online quizzes? At the very end of class, you'll see it on Blackboard under the assignment tab. I completed those questions already and missed that part, so I used up 5 or 10. Email me. If there's also ever a thing where it's like it was Wiley's fault that you lost points because you had to use too many attempts, email me with the question number and I can go back in and I can change things after the fact. What up? Someone had a question in the back or not? Questions? My ear is doing weird things. I don't like it. No more questions? Oh, okay. I could have sworn there was, but all right. Okay. 1-6. Let's get to notes. How about that? We go till 4:05, so that means I shut up at 3:45-ish. Okay. Where's 1-6? Where is 1/6? 1/6. Oh yeah, you were the ones that had the super duper lag that I got frustrated and rage quit. Isn't that what happened last time? Fun. All right. I'm gonna sit down. All right, so we started talking about the natural logarithm just barely because my computer was mad at me. But remember, so essentially these are going to help us undo exponentiation. So we started writing down the first property. So let's write down the rest of them. So the first one was if you have two things that are multiplied together or multiple things that are multiplied together inside the logarithm, you can split up into addition. If we have a division of things inside the logarithm, you can split it up with subtraction. If you have the natural log of something to a power, you can bring the power out. This is like the reason why we're learning about these, because that's going to allow us to bring powers out to be able to solve for them. So the lag has already started. These three are kind of the meat and potatoes. I'll list a couple other ones, but these are, I don't understand. It's just your class. It's like your class works some voodoo magic that makes my computer not want to work. All right, anyway. A couple other ones that are used slightly less, but are also still important that you can't see because it's lagging. I'm gonna throw it out. There we go. And then two more that are used even less than that. Nope, I'm writing the same thing twice. What am I doing? So we have that the natural log of 1 is 0, the natural log of e is 1. And if you have the natural log of e to the x, or if you take e raised to the natural log of x, those both reduce to just x. So those are our properties. You know what? Here's what we're gonna do. I added in these next two examples. I usually didn't do these next two because I don't think I test this idea, but I just wanted to show you how it worked. For the sake of time, since I just took a bunch of time talking about the exam, we're gonna skip them. You don't need to worry about those two. Bye. If you want, I can put the answers up, but we're gonna skip down to the more important bit for the sake of time, which is solving. This is the thing that's going to come up way more and is the basis of your homework for 1/6. So the process for solving equations using logarithms, the first thing you have to do is you have to isolate the exponential term. So you want to end up with something like some a to the x equals p. After that, you're going to take the natural log of both sides. So we'd have something like ln of a to the x equals ln of p. Once again, I think I said this before, if you know how to work with other log bases and you want to use other log bases, go right ahead. You're going to bring the power down. I'm going to say exponent, actually, because sometimes it's more than just a number power, and you usually want to take the whole entire frickin' thing out. So bring the exponent down using log properties. So then you'd look like something like x ln of A equals ln of P. And then finish solving for x using algebra. So in this little simple case that I have going on here, we'd have to divide both sides by the natural log of A. So those are kind of the steps that you're going to follow to be able to solve these equations when we want to solve for the thing that's in the exponent. So let's look at a couple of these. Say I want to solve for t when I have 3 to the t equals 10. First step, isolate the exponential. Already done. I don't have anything attached to this 3 to the t. It's already isolated. Step 1, done. Step 2, take the natural log of both sides. Whoa. Step 3, bring the power out. Step 4, finish solving for, well, in this case, t, whatever variable you're looking for. So I need to get that natural log of 3 away from the t value, so I have to divide both sides by the natural log of t. Sorry, natural log of 3. Punch that sucker into a calculator. You're going to get 2.096. In terms of Wiley, I think they'll usually want the decimal. For me, if you leave it like this, the natural log of 10 divided by the natural log of 3, I will count that as correct. That is technically a correct way to say that. If you want to switch it over to the decimal, that's right too. I'm saying I'll accept either. But with Wiley, I'm pretty sure they always want you to actually write the decimal. Questions, concerns? Yeah, I'll give it a couple more seconds because people are scribbling, although maybe they're getting ahead of me, which is fine. Feel free to work ahead of me if you want. I'm going to go to the right, so I'm going to go to problem 3 next. So now I got to isolate the exponential term. Well, the exponential term is this 8, 6 to the t, so I have to get that 5 away. So to essentially get this 5 over to the other side, since they're being multiplied, I have to divide both sides by 5. $25 divided by 5 is 5. Once I've isolated, take the natural log of both sides. Bring the exponent out. I would suggest taking the entire 6t. If you know what you're doing, you could just take out the t, but I just suggest always taking the whole thing. And then we've got to solve for t, so we have to get t by itself. So I have to move this 6 and this natural log of 8. I often find that some people like to do it in 2 steps, but you can do it all at once. You can just divide the entire thing by the 6 and the natural log of 8 at the same time. Once it catches up to me. There we go. If you want to do the natural log of 5 divided by 6 and then divide that answer by the natural log of 8, or vice versa, natural log of 5 divided by the natural log of 8, take that result divided by 6, go right ahead, whatever floats your boat. Gonna get the same answer. No, let me keep that up. Questions, concerns on that one? Okay. Yep.
So if we keep it like where it is now, where it's like the natural log of 5 divided by 6, the natural log of 8, that would kind of cut it, correct?
For me, yes. For Wiley, I think it wants, and I just wrote the decimal that you'll see in 5 years from now. There it is. Because I forgot to finish it out to a decimal. But yeah, if you leave it as this formal thing, I should be clear. Triple check my instructions. I always, if I want you to simplify, it will say it in the instructions. But usually, I more care about the process and less about how you write the answer. What up, Jackson?
So we got the 6LN on the bottom. Are you when you're plugging into your calculator, would you plug in LN5 and then 6 next to the LN8 after you put the division sign? Or how would you put that in?
You'd want to make sure the 6 and the natural log of 8 are encompassed in parentheses, or else it's going to tell you a different answer than you want it to be.
Okay. All right, thank you.
Yep, so if you ever have more than one thing in a denominator and you're trying to punch it into your calculator, that denominator should go in parentheses.
Okay, that makes more sense.
Alrighty. Next two. We're not doing good on time, but it's all right. So 12, 5, e to the 3t. I need to get this e to the 3t by itself. So I've got to get that 5 over to the other side. You catch up to me, please. Thank you. All I wanted was a little box. Divide both sides by 5. 12 divided by 5 is going to give you 2.4. And then you'll have e to the 3t. Take the natural log of both sides. Why is it so nice sometimes and so absolutely horrid other times? Bring the power out. So bring the 3t out. Whoops. Now we have a little bit of a choice here. The natural log of e is 1. So if you just want to reduce that to 1 and then just divide by the 3, that would be correct. So technically, if I were doing this, I would just say natural log of 2.4 divided by 3 because of the fact that the natural log of e is equal to 1. But if you had the natural log of e down here, you would be completely correct as well. So whatever floats your boat. But the natural log of e is 1, so we can just do natural log of 2.4 divided by 3 to give us 0.292. Yeah.
Do we have to state that we know it's just one properties?
No, you can just reduce it. You don't have to say, I'm reducing this because I know it's 1. And so for this last one, it's slightly different because we want to isolate the e to the t minus 1. But now we have subtraction instead of multiplication. So we're going to have to add 5 to both sides first to isolate that exponential term. Take the natural log of both sides. Bring the entire power out. Now, since that has subtraction in it, put it in parentheses. In this case, it doesn't quite matter because the natural log of e is 1, so that kind of goes away. But if that was a natural log of anything else, you'd have to distribute it first. Well, actually, you could just divide both sides by it. Any algebraic way you could deal with that, you could. But you might not deal with it correctly if you don't have the parentheses around the t minus 1. But natural log of e is 1, so I'm just going to kind of drop it. So we essentially have t minus 1 equals the natural log of 10. So t equals the natural log of 10 plus 1. which is 3.3. Questions, concerns? All right, the last idea in 1.6. I'll leave this up for another couple seconds. Well, actually, I can scroll down a little bit. There we go. The last idea in this section is, so what we presented at first, so this is kind of getting a little scrunched by the things we just did. We were writing things as p naught a to the t. Well, there's another way we could write exponential functions. And there's a completely other form that looks like p naught e to the kt. Now, in these cases, we have these relationships between essentially the thing with the k value and the thing with the a value. And I'll talk about that a bit more in a second. But this k value is going to be called the continuous growth or decay rate. So at this point, moving forward, we might see one example in 1.7, if I can scrap it in there real quick. If you see the word continuous, it will be the e to the kt form. If you do not see the word continuous, it's the a to the t form. So the word continuous is really going to, be our real big tip off of which form we're now going to have to use. Now remember way back when we were starting to talk about exponential functions, we kind of had two options, growth or decay. And it depended on what your a value was. So if your a value is greater than 1, we had exponential growth. And then if a is between 0 and 1, it was exponential decay. We're going to have similar relationships for the k value. So if a is greater than 1, then its associated k value, because we can always find essentially the equivalent form. So even if you're given 1, you can always jump over to the other, which is what we'll see in a hot second. So if a is greater than 1, then the k value would turn out to be positive. So if k is positive, we have growth. I'm going to stop writing the word exponential because I'm being lazy, but it's technically exponential growth. And if a is between 0 and 1, k will end up being negative. So if you're ever given a k value that's negative, you know it's decay. Or if you see continuous decay, that's weird phrasing, but decaying at a continuous rate of, you would know that that would tell you continuous tells you the k value, decay tells you it's negative. Now, again, we can always kind of jump between the two forms. If we have one of them, we can find its equivalent other form. How the heck are we going to do that? Well, I'm going to scroll down really quick, but then I'm also going to go back to this idea right here. Look at those two forms. What is the only thing that's different between those two forms? The a and the e to the k. Everything else is the same. They have a t in the exponent, the p naughts don't change, and the other p doesn't change. So the only thing that's different between the two forms is the a and the e to the k. So to jump between the two forms, use this. Because if they have to be equivalent forms, those two things must be equal to each other. Because everything else is the same. Those are the only two things that could differ. So if we set them equal to each other, they must be the same equation. Or demonstrating the same equation. So say I want to convert to the other exponential form for these ones here. So as I just said, the p naught doesn't change, right? The p naught, it doesn't matter which equation I'm looking at, the p naught's still p naught. So for our new equation, the p naught's still going to be 1000. So we essentially have an e to the kt, and we want an a to the t. Well, p naught is just p naught, and then I'm going to use this relationship that I just told us to use. So I'm going to have a, don't know what that is equal to e to the k, which in this case is 0.05. Remember, e is a number, so you just punch that sucker into your calculator. E to the 0.05. E to the 0.05 is approximately equal to 1.051. you've got all you need. You can write the equation now. It's that simple, and hopefully it seems simple. I should avoid the word simple. So our equation, or in the other form, would be 1,000, and that looks like a 6. 1,000, 1.051 to the t. Done. Oh, Lord. What up?
What number was E again? Like, how do you find that number again?
So you don't want to just like punch in the number, like the value for it. Do you have a TI 83 or 84?
I have an 84.
Okay, so to get E, what you're going to do is you're going to press the second button and then the division symbol, because there's a little E above the division symbol. And that's how you'll get it.
Okay, thank
There's
you.
another way you can do it, but let's just go with that one. If you know the other way, use the other way. Okay, now for the sake of time, I'll leave this one to you. Try it later if you want. If you don't. I don't know. I'll have the answers up on Blackboard. But let's jump to now doing the opposite way. So once again, P naught doesn't change. So P naught is still 500. We're still going to use this A equals E to the K form, so I haven't filled it out yet. But this time we have A, so 1.06 equals E to the K. But now since I want to solve for K, I have to take the natural log of both sides. And I'm going to do 2 steps at once, and hopefully that doesn't freak anybody out. I took the natural log and pulled the E out, the K out at the same time. Log of E is just 1. So at this point, you can just punch natural log of 1.06 into your calculator. That's going to give you, I'm running out of space a little bit. Let me, oh, I can't move things on here, I forgot. So K is going to be approximately equal to the natural log of 1.06, which gives us 0.058. And I guess I'll go backwards to write the equation. Once you have those two things, you have your equation. You have your P naught is 500. We want an E to the KT, so we have E. The K value we just found was 0.058 T. And it's got a, there we go. Questions, concerns? I'm going to also leave that one to your own devices. Because what I want to do really quick before the quiz, because I don't know what the heck the pacing of this semester is. I've never been this far behind in my life. I'm going to jump over to 1.7. Now, the reason I feel comfortable doing that is because 1.7 is essentially just using exponential equations and logarithms and just more word problems. So technically you have almost everything you need to complete 1.7. It's just that they're word problems. So I want to jump over there super quick, give you the one thing that you don't already have for it. Where did I just, oh, well now I gotta, well now I messed it up. I messed up. Gotta share it over here. So we will finish 1.7 on Tuesday and also cover 1.8. I'm probably going to scrap half of 1.8 and just cover the important bit, so it should work out fine to do it all on Tuesday. So I'm going to skip this first example. You technically already know how to do this. You do. This first part, so we're essentially, no, actually, no, because we do it in the next one. You know how to do this except the fact that it says continuous now. So let me set this up, but then I'm going to come back to it on Tuesday. So here's, nope, No, I'm not. I'm going to save myself time and scroll down here, and I'll come talk about it at the end before we take our quiz. And I'll show you exactly why you already know how to do it. So this is the one kind of extra bit you need for 1-7. The doubling time. For an exponentially increasing quantity is the time required for the quantity to double. So obviously it has to be increasing if you want it to double. And then the half-life. If you've ever done chemistry, you've probably heard that before in your life. The half-life of an exponentially decaying quantity is the time required for it to be reduced by a factor of 1/2. So say I want to do this question where it says the release of chlorofluorocarbons used in air conditioners and household sprays destroys the upper atmosphere. The quantity of ozone is decaying exponentially at a continuous rate of 0.25% per year. What is the half-life of ozone? So the main thing we kind of pull out here is we use more of the continuous situation. So the continuous, whenever you see the word continuous in these exponential functions, questions, it's this format instead of the a to the t. If you just see the word rate, it's a to the t. If it's got continuous in there, it's e to the kt. So we're given the rate. I underlined it. There we go. So we're given the rate. Now, usually we would say R, but since we have a K floating around, I'm going to use the actual variable in the name. So the rate for continuous are called K instead of R once it catches up to me. And we have to change this over to a decimal, just like with R. So it's going to be 0.0025. I'm also missing one tiny other piece on that. Does someone realize what it is? If I say that this quantity is decaying exponentially, what should I have in front of that number? A negative. Since it's decaying, the rate's going to be negative. Now I want to find the half-life. Now I'm not given P0. I don't know the initial value here. I don't need it. Okay, so for these doubling time and half-life questions, you don't need the initial value. If it makes you happier, pick a number, but you don't need to. You don't need to pick a number. Here's why. Let me write down what I have. So I don't know what P0 is, but I know that K is negative 0.0025. Just wait a second. Let me try unsharing and resharing. I don't have time for this. There it is. So that's all I know for my equation. That's all I have. But when I ask about the half-life, I want to know the time it takes for the initial value to be cut in half. So that means I want the final value to be half of what I started with. Half of what I started with. I don't need to know what it is. I just say it's half of that value. I don't care what it is. Because if I want to solve for the time, the first thing I would start to do is to isolate this exponential. So if we wanted to isolate this exponential, the first thing you do is divide both sides by P0. Eventually, when you divide both sides by P0, all the P0s cancel out, which is why we don't need it. And we just end up with 1/2 e to the negative 0.0025t. We know how to solve that. That's what we just started at the very beginning of class today. We learned how to solve that. Take the natural log of both sides. This is why you already know how to do most of this section. You just don't realize you know how to do it already. Natural log of e to the negative 0.0025t. Bring the power out. Oh my lord. If you want to recognize that the natural log of e is 1, go right ahead. So to solve for t, we just have to divide both sides by that, that rate. Plug that sucker into your calculator. The answer will, there we go. Now it just looks like I write a lot of stuff in like a second. If this were a doubling time problem, you would just use 2 Q0 or P0 instead of 1/2 P0 because you want it to double instead of be cut in half. So that's how that goes. The tiniest last thing I'm going to say, because again, you already will know how to handle these problems, but the wording might throw you off if I don't tell you what the wording means. Are there questions on this one? So because we had continuous, we had to use this new form. You'll also be asked questions about interest. Again, you already have everything you need to know to answer these. The only thing you need to know is when it's talking about annually versus continuously. If you're talking about annual interest, you'll want to use an equation that looks like this, which suspiciously looks like this. If it says continuous, you want to use something that, well, in terms of interest, it's usually written as r to the t. That's just usually the way it's presented when it's in terms of interest, but it's just the continuous versus not continuous again. So if you ever have a specific interest example, same idea. If it says continuous, use e to the rt. If it doesn't say continuous, use a to the t. You have everything you need to do 1-7. You might want to see some more examples, but we'll get to those examples on Tuesday. Once again, apologies that we didn't finish it beforehand. I don't know what's happening. But again, all the stuff you need to complete it, you have. You just might not realize it, but it's all there. So on Tuesday, we'll finish this. We'll go through the little tiny bit of 1/8 that we need to get through. And if we have any time left, we can review a little bit, but we might not have any time. It's also online, so the things I usually do for review don't really work. I don't know. Anyway, so let me stop the recording for these people. Let me